Hey everybody, how you doing? We have a short chapter here. It's only going to last 8 days, and it's kind of an introduction to conics, and we'll talk about what conics are in a couple days. Actually, we'll probably talk about it tomorrow or today, whenever you're watching this. But the first conics we're going to be looking at is just circles and ellipses, and today we are just doing the raw. Um, Here's the equation, and here's a simple graph of it. We'll get into more complicated graphs in a couple days, hopefully, with these. Anyway, the equation for a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. In that equation, the center is at h and k, and the radius, it says r squared. Well, the radius is just r. So if it says like equals 25, you know that the radius is 5. Okay, now in an ellipse, h and k also means the center point. Oh, wait, you're like, what's an ellipse? Well, I've never heard of an ellipse. What's an ellipse, Elliot? Um, I don't know why they call it an ellipse. When I was a kid, it was called an oval. And then you get to high school, and they're suddenly calling it an ellipse. Why can't we call it ovals? I don't know. I guess we have to grow up. But the center for the oval or ellipse, I'm going to call it ellipse from here on out, is also HK. And then in this case, instead of having an equals r squared, it's kind of like they took the circle equation and divided everything by r. But at the end of the day, the letter A here represents the horizontal stretch. It's the best word I have for it. You'll see what I mean when we get to graphing it. Horizontal stretch, TCH. And if A represents horizontal stretch and that's what's hanging out with the X, what do you think they call the B? That's right. It's called Steve. Oh, not Steve. It's called the vertical stretch. Steve. I cracked myself up. Once I get into the examples, we'll talk about what this horizontal and vertical stretch really means. Let's get into some examples. That's example 3. Example 1. They give me an equation like this, and it probably actually wouldn't even read like this. It would probably read equals 64. So x minus 3 quantity squared plus y plus 4 quantity squared equals 64. Well, based off of what we saw before, that means that the center is going to be at 3, negative 4, and the radius of it is 64. The square root of 64 is 8 squared. So the radius is equal to 8. Now we're going to get into graphing this. Look, it's a circle. I know what the graph's going to look like. I'll take that. Thank you. So I know the graph is going to look like this. Check out a free-handed Elliott circle. Whoa, that's round. All right, the center right here. You can do this on graph paper, by the way. Just make sure you put your center at 3, negative 4. Then, circles and ellipses, I need you to include 4 key points. And if you're using graph paper, just simply get to your coordinate and go, this way or to the right 8, up 8, left, right 8, down 8, and make big dots and connect all your dots. If you're not using graph paper, you need to kind of think, well, what happens if you add 8 horizontally? Well, that's adding 8 to the x coordinates. That would make this coordinate 11, negative 4. If you traveled 8 in the opposite direction, you'd be at negative 5, negative 4. Y coordinates up and down, so the x coordinate stays 3. If you go up 8, it becomes positive 4. If you go down 8, it becomes negative 12. So all those key points listed. All right. Any questions? No? Okay. If you like to do this little business, you can. But what's really important are the 5 key points. Number dos. Same thing about the center. I got the center is at, it's inside this function, so we're going to go with opposite. So it's at negative 4, positive 5. So that's going to be my center point here, negative 4, positive 5. Now, this one is over 9, which means horizontally, square root of 9 is 3, so horizontally it's going to stretch 3 in the horizontal direction. Vertically, it's over 16, so it's going to stretch 4 in the vertical direction. So as I draw my ellipse, I'm going to make it like a little more vertical than horizontal because the vertical stretch is more than the horizontal stretch. So because this is divided by 9 and square root of 9 is 3, that means horizontally you go 3 units. So that would make this positive, or excuse me, -1, +5 if I traveled 3 units from -4. If I traveled 3 units from -4 in the opposite direction, that would be at -7, +5. Vertically, square root of 16 is 4. If I go up 4, that would put me at -4, 9. If I go down 4, that would put me at -4, +1. And same thing I said about last problem if using graph paper. Just graph your point here, go 3 horizontally, 4 vertically, connect to the dots. La 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 la. All right, those are forwards problems. Next, we're going to be opposite problems. And on those, you're going to be writing an equation. Well, it tells me right here that the center is at 4, 3. They usually won't tell you that. I found this on the internet. Thanks, internet. But if I have 0, 0 here and I'd go to this point, it'd be 4, 3. So x minus 4 quantity squared and y minus 3 quantity squared. And then it equals r squared, so you just count up the radius. And you go up, down, left, or right. They had this nice dark line for me. Appears to be a distance of 5. Maybe for redundancy, just check it in one of the other directions. I also got a direction of 5 down. So that is equal to 5 squared. But you wouldn't write 5 squared because everybody knows that 5 squared is 25. Don't write 5 squared. All right, last one. This one's an ellipse, and we need to write ourselves an equation. But the center is at -2, 5, so it starts the same. X plus 2 quantity squared. And over here it'd be y minus 5 quantity squared, and there's going to be a plus in between them. And because it's an ellipse, it's going to be equal to 1. Then look and see how far you went horizontally. It's going from -2 to 0, which means it's a distance of 2, which means I need to put a 4 here because it's over that horizontal stretch squared. Vertically, it's going from 5 up to 8, or in the other direction, 5 down to 2. No matter which way you look at it, that's a distance of 3. So this would be over 3 squared, which is 9. That's it. Not much to graphing circles and ellipses. Tomorrow in class, that's actually one of those lessons that I think it's probably going to take me longer tomorrow to explain the concept than it is to just take the equation information that I gave you at the beginning of the lesson. Oh, yes. And it's kind of the key information right here. Once people have this key information, they tend to do pretty well with these problems. It's understanding the concept that's tricky, and we'll try to figure that out in class tomorrow on Wednesday. Well, that's all I have for you. I hope your math test today went awesome, and I hope your day's going well, and I'll talk to you soon. Bye-bye. Oh, happy Pi Day.